Welcome to this explainer. Let's jump right in by looking at a pretty wild connection. Think about the stuff you interact with every single day. I mean, what actually links the towering office buildings we work in, the crazy powerful smartphones in our pockets, the autonomous cars on the road, and those daring space missions we're always reading about? On the surface, they seem completely different, right? Different industries, different goals. But they all share the exact same origin story.
Because everything around us, literally everything, starts as just one thing, an idea, a little spark of imagination. But how do those abstract concepts actually cross over and enter the real world? Because, let's be real, an idea on its own is totally weightless, it's invisible. To actually become a functioning suspension bridge, or a reusable rocket, or a life-saving medical device, an idea needs a structured process. It needs a massive driving engine to push past the friction of turning the abstract into something tangible.
And that driving engine? Well, it's engineering. Here in the United States, ideas are systematically turned into reality through the rigorous, structured methodology of applying physics and math to solve really complex problems. It's not magic, even though it definitely feels like it sometimes. It's just the incredibly practical, scalable application of science to physically manifest ideas. Today, we're going to peek under the hood and look at how this methodology actually operates to build the world around us.
So, here's our roadmap for today. We'll start with building the nation, move right into the digital revolution, transition up to exploring the cosmos, take a look at where engineers are made, and wrap the whole thing up with the future of engineering.
Okay, part 1. Building the nation, the physical foundation.
When we look at modern infrastructure, it's essentially this massive, interconnected web powered by 5 key branches of engineering. You've got civil engineers laying down the physical groundwork. Mechanical engineers are building the complex machines to travel on it. Electrical engineers are quietly powering the whole grid. Software engineers, they're giving that grid a brain with modern apps and AI. And then aerospace engineers are taking all of that and pushing the boundaries upward. Each discipline has its own distinct lane, but they are all deeply, deeply connected.
And the sheer scale of how these fields overlap is just staggering. Civil and mechanical engineers have to work together seamlessly to physically construct our environments. I'm talking about ensuring the structural integrity of those massive skyscrapers towering over New York, and designing the incredibly resilient bridges that keep our supply chains moving. And right now, as we speak, they are laying down the smart highways and complex sensor grids that serve as the absolute baseline for the high-tech smart cities of tomorrow.
Moving on to part 2, the digital revolution, powering the invisible.
Now there's this really visceral contrast between the heavy steel of the physical infrastructure we just talked about and the invisible web of the digital world. This digital realm doesn't rely on concrete beams, right? It relies on artificial intelligence, cloud computing, and massive global networks. This is the world of software engineering, the absolute lifeblood of hubs like Silicon Valley, using pure code to build systems that are every bit as critical to our society as our physical highways. The output of all this digital engineering literally dictates the pace of our modern lives. Think about it. We're dealing with artificial intelligence and self-learning machines that can adapt instantly to new data. We've got smartphones that literally billions of people rely on just to get through the day, completely powered by cloud computing networks that hold our collective human knowledge. Tech giants like Google, Apple, Microsoft, and Tesla absolutely depend on these exact digital architectures to scale their innovations worldwide.
Which brings us to part 3, exploring the cosmos, beyond Earth.
If you track the timeline of aerospace engineering, you're essentially watching the systematic expansion of human capability. In the past, we started by pulling off the unthinkable, landing actual humans on the moon. Fast forward to our current era, and NASA engineers are just casually sending highly complex autonomous rovers to analyze the dirt on Mars. And now, we are rapidly launching into a totally new era, driven by incredibly powerful reusable rockets like the SpaceX Falcon. It's the logical, albeit totally mind-blowing, extension of our engineering power, expanding way beyond our own atmosphere.
All right, part 4, where engineers are made, education and dreams.
You might be wondering, where do the minds driving all this crazy R&D actually come from? Well, they're often cultivated at some elite institutions. Places like MIT, Stanford, Harvard Engineering, and Caltech act as these ultra-high-density incubators for technological breakthroughs. Honestly, at these universities, the barrier between a classroom project and a massive commercial application is practically non-existent. A lot of the fundamental tech architectures we rely on today started right inside these exact research labs.
And the way they teach at these hubs, it goes way beyond just memorizing a textbook.
The theoretical frameworks these students learn are immediately put to the test through hardcore hands-on experimentation. They're getting their hands dirty, building prototypes, running intense simulations. It's that messy cycle of building, breaking, and iterating that actually yields true innovation. It's literally a structured pipeline designed from the ground up to produce breakthrough thinking and execution.
And finally, Part 5, the future of engineering. What comes next?
Look, engineers definitely aren't just sitting around resting on past achievements. In labs across the country right now, AI robotics are being designed to assist with nuanced everyday human tasks. Our entire transportation grid is pivoting incredibly fast toward advanced electric vehicles and, even aerial mobility. Zooming out, massive sustainable energy grids are scaling up globally, while aerospace logistics teams are quietly prepping the intense life support architectures we'll need for crewed missions to Mars.
I want to leave you with a final thought to chew on as we wrap up this explainer. When imagination meets technology, impossible becomes possible. Because the entire modern world, from the depths of our digital networks to the absolute furthest space probes, was built just one single idea at a time. Engineering is simply that rigorous methodology that bridges the gap between what we can dream up and what we can physically touch. So the next time you're looking at the systems powering your life, I challenge you to ask yourself, what impossible idea will you help turn into reality?